Steel Dynamics is a leader in the mini-mill steelmaking industry with a focus on value-added products with demanding quality requirements. And at the heart of the mini-mill process, a more environmentally friendly way of making steel is scrap steel. Lots and lots of scrap steel. In fact, over 90% of the material SDI uses to make new prime steel consists of scrap steel that has been reclaimed from end-of-life infrastructure, factory machinery, agricultural equipment, automobiles, appliances, material that was often left to rust in junkyards or litter the countryside. Environmental issues are a concern for all of us, and no one in the steel industry is doing more to help the construction industry than Steel Dynamics. Regardless of the product, our recycled content, a critical issue for LEED certification, runs in excess of 75%, and in most cases, considerably more. SDI also owns OmniSource, the second largest scrap recycling company in North America, and that's where our story begins, at an OmniSource facility in Indianapolis. OmniSource collects and processes ferrous scrap and non-ferrous scrap at more than 70 facilities around the country. Here at one of OmniSource's 5 facilities in Indianapolis, a gigantic shredder reduces entire automobiles and other large pieces of scrap into smaller sections that will fit into our electric arc furnaces. After the scrap is shredded, giant magnets separate the ferrous materials from the non-ferrous. Non-ferrous scrap is conveyed away for further sorting. Just as in the mini-mill steelmaking process, nothing goes to waste. At a visual inspection checkpoint, employees remove any non-ferrous scrap that's hung up with the ferrous material. Some of that ferrous scrap is destined for our structural and rail mill, SDI's second greenfield mill near Columbia City in northeast Indiana. Opened in 2002, the structural and rail mill has an annual capacity of 1.8 million tons. Our structural and rail mill is unique to North America. In addition to making structural products, we've also become a leader in the production of rail for America's Class I railroads. We can also produce feedstock to complement our engineered bar products mill at Pittsboro, Indiana. At the structural and rail mill, we have 2 rolling mills, the heavy section and medium section mills. In 2010, we added a second caster to increase our capacity and versatility and to meet our customers' needs. The 700-acre structural and rail mill campus includes 15 miles of railroad track capable of handling 700 rail cars at one time for incoming scrap and outgoing steel shipments. The mill also receives 200 to 300 truckloads of scrap and other raw materials every day. It's a 24/7 operation that runs close to 365 days a year. 3 30-ton scrap cranes and large front loaders facilitate moving the scrap around, in and out of rail cars and trucks, and to the scrap bay at the edge of the melt shop, where large magnets transfer the scrap into a charging bucket. Scrap is loaded into the charging bucket according to grade to achieve the exact chemistry necessary for our steel products. Each furnace heat consists of 120 tons, with at least 75% of it scrap. Mini mills use electric arc furnaces, or EAFs, which require much less in the way of natural resources versus traditional blast furnaces. For every ton of steel produced by SDI, we eliminate the need for 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. And we use significantly less energy in the process. The EAF process also produces 67% less carbon equivalent emissions. In addition, 95% of our scrap comes from within 250 miles of our plants. The charging bucket is moved to a position directly above one of the mill's 2 EAFs. The scrap is then released into the furnace, creating some real fireworks. And it's exciting. The reason for the explosion is that a portion, about 40 tons, of each heat of molten steel is left in the furnace to keep it hot for the next heat, saving time and money. The roof of the furnace is closed, and 3 large carbon electrodes are lowered through an opening in the roof. Then, it's showtime. And it's loud, very, very loud. The rods circulate or arc up to 115 million watts of electricity to melt the scrap at a temperature reaching 3,000 degrees Fahrenheit. The power is on for about 35 minutes to complete the melting of each heat. Once a heat is completely melted, the furnace is tipped to pour off the slag, a collection of impurities that rises to the top of the heat. Here again, nothing goes to waste. The Structural and Rail Division sells more than 200,000 tons of slag each year. Slag's primary use is as a substitute for mine gravel. The molten steel is then tapped through the bottom of the furnace and into a ladle. The steel then goes to the ladle metallurgy furnace, or LMF, where a variety of processes can be accomplished, including desulfurization and deoxidation. The temperature of the steel can be adjusted with carbon electrodes, and the chemistry of the steel can be changed by reducing some alloy elements and the introduction of others. The steel is also mixed using argon gas. Our 2 EAF and 2 ladle setup enables us to continuously provide molten steel to our 2 casters. After the LMF process is completed, the ladle is placed on the casting turret and rotated into casting position. In the first part of the casting process, the steel is released into the tun dish. Steel streams out of the tun dish through a funnel shroud and into the mold, which oscillates so that the steel doesn't stick to the mold. Here's a look inside the casting control pulpit, where operators carefully monitor all the casting parameters. Rather than being pushed, the strands are pulled from the caster. At the bottom of the caster, the newly formed strands, now called beam blanks, are cooled with water. The beam blanks are then picked up and placed in the reheat furnace. Reheated to more than 2,000 degrees Fahrenheit, the beam blanks are made softer before entering one of 2 rolling mills. The discharge machine takes beam blanks from the reheat furnace. After exiting the reheat furnace, the beam blanks go through a descaling machine to remove oxide scale created during reheat. The scale is removed with water jets, spraying with pressures in excess of 3,000 pounds per square inch. In all, we use nearly 200 million gallons of water per year to operate and cool our processes. That water is recycled on-site and reused. From the descaler, the beam blanks go to either the heavy section rolling mill or the medium section rolling mill, depending on the size of the product. It's in the rolling mills that the beam blanks are reduced and formed into the various final products. In the heavy section mill, larger products go through 2 rolling mills, the breakdown mill and the tandem mill. The one-stand reversing breakdown mill is driven by a 7,500 horsepower motor. The mill rolls the beams between 5 and 11 times, depending on the size of the final product being produced. Next, the beams are transferred to the 3-stand reversing tandem mill, where the beams are further reduced by rolling, but exit longer at up to 320 feet sections that can be cut to smaller lengths for customer orders. Now let's take a look inside the medium section mill, where lighter products are made. On the 15-stand non-reversing medium section mill, beams are reduced during continuous one-pass rolling. The resulting beams can be up to 1,000 feet in length before being cut and placed on the cooling bed. From the pulpit, an operator closely monitors the medium section mill. After rolling in the medium section mill, the beams are sheared to various lengths. Here, still hot beams are being knocked off onto the cooling bed. The 3 glowing pieces shown here came out of the mill as one piece. The beams go through a straightening machine before being cut to customer lengths with a friction saw. Ready for shipping, the beams are stacked for bundling with power manipulator magnets. In the shipping area, these H-pilings are being prepared for loading onto rail cars. These 14 by 14 inch H-pilings weigh 70 pounds per foot and are often used in bridge abutments to create strong foundations. Here, a forklift is used to load beams, 21 inches wide with 6.5 inch tall flanges, onto trucks for shipment. This type of product is often used in non-residential construction, such as in the building of a big box store. At our structural mill, we produce wide flange beams in section depth ranging from 4 inches to 36 inches, W4 at 13 pounds per foot through W36 at 256 pounds per foot. Structural channels from 8 to 15 inches, 8 inches at 11.5 pounds per foot through 15 inch at 50 pounds per foot. Manufactured housing beams in web heights from 8 inch to 12 inch, MB8 at 6.5 pounds per foot through MB12 at 11.8 pounds per foot. And H-piling in 8 by 8 inch at 36 pounds per foot through 14 by 14.5 inch at 117 pounds per foot. At Steel Dynamics, we're driven by our commitment to our customers. We provide a broad range of products, versatility and flexibility, innovative processes, and the shortest lead times in the industry. Our customers, in turn, are building a better America with steel made in the American heartland.